equals, so n equals 4. And what I'm doing, remember, trapezoid rule approximates an integral. So before we learned how to actually evaluate this integral, we used rectangles, trapezoids, and so on to evaluate the area under the curve. So you have to know how to find the area of a single trapezoid to use trap rule, right? So how do you find...
It's h over 2 times
Six.
c1 plus b2.
Did I say 0? Yep. Sorry, that's a 6. Okay, say that again. That's right. That's the area of a single trapezoid, right? So what I'm doing is I'm finding the area of 4 trapezoids and adding them together. Are y'all with me? So this is going to be, and if you look, here's trap 1, 2, 3, 4. What is wrong with y'all? Do y'all not remember this?
No, I remember it.
Okay.
Yeah.
Yeah. This is the distance between your x's that's gonna be your h each time. And it's not always, when you got a table of values, it's not always the same value. Okay? It might just be, I don't even know what y'all are talking about now, but this is going to be base 1 and base 2. And then for the next one, this will be base 1, base 2. And then for the next one, this will be base 1, base 2. And then for the last one, base 1, base 2. Right? So a lot of times you'll see us simplify. Everything gets multiplied by half. So I leave that on the outside. Well, the height of this, it's h over 2. It's 1/2. You know how a triangle is 1/2 base times height? This is 1/2. The two bases added together times height. So I pulled the 1/2. You don't have to pull that 1/2 out. If you want to find each, that's fine.
I did pull one out.
Okay, I'll leave it. Okay.
But I mean, that's just because I forgot how to do it.
Okay, but let's. Okay, but okay, so we don't have to. I won't pull it out.
Yeah, I feel like it's, I don't know, I like pulling it out, but I just kind of forgot. I mean, I'm not saying not to pull it out, I'm just saying I just.
Shut up.
1/2. Height here is 2, right? From 0 to 2 is 2. And then I've got base 1 plus base 2. There's the area of one trapezoid. Plus 1/2. This is 2 again. 2. There you go. See why we took that 1/2 and put it in the front? Because, I mean, it's there every time, so it's... That's right. This time it's 1. That's fine.
Does that mean that, well, those should just cancel out for this?
What was
One
canceled?
half, 1/2 and the
For that piece right there, yes. I would advise you to write it all out, though, because a lot of them will give you a point for writing it out. So write it, yeah. 1 times, and then we got 13 plus 16. That's 1, 2, 3. We have one more. 1/2, 1 times 16 plus 18. So yes, Noah, we cancel here for those. And then, do y'all need me to finish working that, or can you take it from there? It's just the setup you needed. Does that clear things up for chapter rule? Do I need to do another one, or are y'all okay? Okay. Volumes of rotation. Let's do volumes of rotation, then we'll use the same one to do a cross section. How about that? But they're all easy once you get, they're all the same thing pretty much. You need, 412 or 422. The thing that helps me the most with these is a picture every time. If you have to ask, would it be wrong? It's probably wrong. I want to do a good one like you had on the. Let me pull one of those. Here we go. Region R is bounded by. What are y'all doing? Oh my goodness. Bounded by y equals x squared, the x-axis, and the line. This would be a no calculator, I would imagine. And the line y equals 4. Why are you throwing stuff at Aaliyah? Nope. Look, you made me write the wrong thing. And the line x equals 2. What is the volume if you rotate R about the line y equals 4? To find the volume, all we're doing is finding the integral. These are going to be your intersection points, right? And this is intersection, intersection. This is however you find the area of your shaded region. That's all that is, okay? And once you find that, that's what you're going to use your picture to do. So what I always do is I set up and say, how do I find this? Same thing's going to happen with the cross section. I always come off to the side and say, how do I find the area? But we'll get to that in just a second. So let's draw a picture. This is x squared, right? It's bounded by the line. All right, so x squared is a parabola. And then bounded by the line x equals. So I'm talking about this region right here. No, don't cross section yet. I'll do cross section next. But it says you're rotating about the line y equals 4. So I need to put that on here because what's going to happen is 4. Yeah, you got it right. Y equals. This is why a picture is so handy. So remember, I'm going down. I'm measuring from any place it measures from the curve down to the x-axis, right? I need to know, this is what I need to know, right? But because I'm rotating it around this line, that's the whole thing. Can you see that?
So x equals 4 is the whole thing. Well, are we looking this way? So which way are you?
Okay, so we're rotating. We're going to take it and rotate it around that black line.
Okay,
Bless
so
you.
We're looking at the whole thing.
Okay, so the whole thing is 4, but look at what, if I take this, okay, so I'm going to have to do some subtraction. That's right. So this area I know, right? That's fairly easy. But because I'm rotating around, okay, let me imagine this piece rotating around. Okay, rotating around that line. To find areas, I know I'm gonna have this donut looking thing, right? It's gonna have a hole in the middle. So to find the area of any circular region, right, it's pi r squared. So I need to find, the first thing I need to find is the radius of the whole thing, and it's 4, that's right. And the radius of the whole, but wait, that is x squared, but that's not, it's 4 minus x squared, that's exactly right. This part is x squared, but if you think about what's being rotated around, right, I've got the whole thing, now I need to subtract out the white part, right, that whole. The part with no shading in it. So what is this distance? Because that's the whole. That's where there is no space. That's 4 minus x squared. That's exactly right. Once you find the radius, the rest is downhill, okay? Because how do you find the area of a circle? Pi r squared. So the area of the whole thing is pi r squared, which is 16 pi. And the area of the whole is pi. It is. So you've got to draw that picture and look at where your white space is, because your white space is your hole, your H hole. And a lot of these just say write but do not evaluate, or it's a calculator problem, right? So here.
Okay, so since we're dealing with y values,
you're not, when you're doing a rotation around the x-axis or a line y equals, you're doing it with respect to x. The only time it changes with respect to y is if you're doing a rotation like this. So if this instead, that would look like if my line of rotation was here or here, and I'm measuring this way for my radii. Right, that's correct. So here my volume would be, now of course, I need to find this point, right? But they already told me, not that point, sorry. This point. That is x equals 2, is that line, right? So I'm going from 0 to 2. 0 to 2. And again, I can take that pi out and throw it on the outside since it's in both, but you don't have to. Because it said it's bounded by the line x equals 2. Well, it stops there. There's no more area because it hits 0, 0 there. So I'm going to go from 0 to 2. I'm going to do, remember, volume is just the integrated area. That's all it is. So that's right. So 16 pi minus 4 minus x squared times pi. If it's most of them at this point are going to say, write but do not evaluate, or it's going to be a calculator problem, you're going to plug it in. They're going to want to see that, and then you plug it in the calculator and find it. But if you didn't, let's say you didn't and you had to do this thing by hand, I would take that pi out of both of them first and put it on the outside, because that's a constant you can factor out of both. So now I have 16 minus, this is going to be 16 minus 8x squared plus x to the 4. This just becomes a lot of algebra now. 16 and 16 are gone. This is 8x squared minus what? Why? What thing? What did I do? Okay, so this is 16 minus 16 plus 8x squared minus x to the 4. Because that subtraction sign distributes through there. I don't have my shoes on right now. You mean to do this? Okay, antiderivatives. This pi just keeps sitting out here. That's right. 8 over 3x minus 1/5 x to the 5th. This is being evaluated from 0 to 2.
I got it right.
Now let's plug in 2. This is going to be 8/3 times 8 30 minus, of course, the 0. Still Dylan? Keep going. I think you're just seeing if I can do these fractions. 32/5. Well, I'm extra. 20, carry your 2, 30, wait, 20, 32, 96, this is 15,
Yeah.
is that right?
24.
Well, there it is. All right, let's switch it to a cross section and see what happens and how it's different. Let's say, let's just use the same example just for the sake of simplicity. So,
Can we do each one cross section?
what do you mean?
So number 2, triangular, square.
I can set it up for you. I can show you how to set it up. So let's say we have the same y equals x squared, still bounded by the line, what was it, x equals 3, wasn't it? Oh, you're right, I'm wrong. X equals 2, so I'm talking about this region. Let's say that the cross sections here are squares. So if I find the volume using cross sections, and the cross sections are squares whose bases are perpendicular to the x-axis. That means that's a base, right?
Would it ever be in any other orientation?
They could be with respect to y, so it could be, most of the time though, if you're talking about cross sections on the exam, it's going to be with x. So here the square, of course, so remember volume is just the integrated area. Upper bound and lower bound, right? These are the intersection points. Same thing, it's the exact same thing. The only difference is now instead of rotating to find volume, now I'm using cross sections to find volume. But still, if I can find the area, well, how do you find the area of a square? Side squared. So what's the side length here? All right, wait, don't go back to the other problem. Look at this one.
Oh.
We're not rotating about y equals 4 anymore. Now we're just looking at a basic, what's that length there? X squared. So square it to find the area. Yes. So the volume would be, I'm still going from 0 to 2, x to the 4th. More likely than not, though, yours will be a little more complicated than that. Probably something along the lines of, what if it was a rectangle whose length was twice its height, whose height is perpendicular to the x-axis? Do I? What do you mean? And then you plug in that. You can, yes, you can do that. My brain is a little slower than that as it works to process that. And I go, well, if I know that this is twice this, right? 2 times whatever that is. You're just using h and I'm using length and width. That's why. Yeah, sorry. So, well, it's not 2 L's, it's 2 W's. If the length is twice the width, L is 2W. So my area of 1 is 2W times W, right? Which is 2W squared. Well, what is W? W is your x squared. So the area is 2. I'm just going to replace W with x squared, and now I integrate again. That make sense? It's all integrating area. The biggest thing, you find your area formula and then you integrate it. That's it. Every single time. This one, the square one. So if you have a square whose side lies in region R and is perpendicular to the x-axis, that means this little purple line is the side length of the square, right? What is that distance? That's x squared, right? So I've got this square, all sides are the same, and one side is x squared. How do you find the area of that? Well, the area you would do x squared times x squared, right? And then you integrate that for a square. But whatever the shape is, you use that. What if it had said circular cross sections? Pi r squared, what's your r? What if it had said semicircular cross sections? Whatever the shape is, you use it. This is what you're using, and you find the equation for the area, and then you integrate it, and you've got the volume.
Where did the x equals 2 come in?
Where do you see x equals 2? That's that line. It said it was bounded by x equals 2. That's your bounds here. If this had been, if that had been x equals 5, then I'd be from 0 to 5. Or maybe it said between the lines x equals 1 and x equals 10, then you'd be going from 1 to 10. That's just, yeah. If you draw a picture, it really, really, really helps. All right, y'all okay there? Related rates? Or you want to save it? Save it? Okay.